Hi, so this is a simple 2-transistor amplifier to amplify the signal from an electret microphone for a simple intercom circuit. So what I've done, I've simulated it on Tinkercad and just so we can see it in simulation. So I'm just going to start the simulation. So that's just ramping up and getting started. So this is our incoming signal. So this would be from our electret microphone, and this is our output signal. So you can see how much it's amplified between the two oscilloscopes. So this is a great tool on Tinkercad to use to check your circuits. And then what I'm doing is using this function generator to simulate the input from the electret microphone, because there's no actual microphone on Tinkercad. So I'm using this to simulate the output from a microphone. So I've just set it at 1 kilohertz and 50 millivolts. So that's a sort of similar output to an electret in the audio range of frequency, and this is about the voltage you'd expect from that kind of microphone. So these are the two stages. So this is our common emitter amplifier stage. So this is just basically a pre-amplification stage, and these two resistors are to set the bias on the base of our transistor. So the signal comes through this capacitor and then feeds into the base, and that's biased with these two resistors. Then this is our collector resistor and our emitter resistor, and then we design this so we set this voltage about halfway. So we want this about 4.5 volts, so it swings up and down freely. And then this capacitor is our bypass capacitor, and that improves the amplification of our transistor. So this is effectively our preamp, our common emitter amplifier, and then the signal gets taken from the collector through this capacitor that takes away any DC to the next stage, which is a common collector amplifier. So this is our power amplification stage. So the collector is constantly connected to VCC, which is the positive 9 volts. We're still biasing, so we've got a bit of bias here so the base is already biased, so the small signal can have an impact. And then what I've done is simulated the speaker with an 8 ohm resistor. So it's not exactly perfect, but it's enough for this simulation. So this resistor represents our speaker, and as you can see, it gives a nice simulation of what we can expect from our circuit when we actually build a prototype. So I've got a write-up on my instructables which explains this in more detail, and it goes into the maths of designing this circuit. But I was quite impressed with the way Tinkercad actually simulated this. So thanks for watching. Check out the instructable for more details.